Hello, and welcome to Architect of Sleep. Tonight, we are leaving the noisy world behind to travel to the silent sleeping worlds of our solar system and beyond. It is a place of deep quiet, where giant spheres drift in the dark, following paths that were set billions of years ago. Here, time is measured in slow orbits, not in busy hours, and the only sound is the gentle hum of gravity itself. For now, just breathe, let your eyes grow heavy, and allow your mind to soften. Our journey begins now. Our journey begins near the sun, with a tiny, quiet planet named Mercury, a world where time itself seems to stretch and slow down. A single day on Mercury, from one sunrise to the next, lasts for 176 Earth days. Imagine a morning that lasts for weeks, a slow, gradual dawn that takes longer than an entire season on Earth. This is because the planet turns on its axis so very slowly, a lazy, sleepy rotation. The sun crawls across the sky at a pace your eyes can barely detect. A cosmic yawn that stretches on and on, a world where you can watch the morning unfold at the pace of a growing tree. There is a strange rhythm to Mercury's sky, a cosmic dance that happens nowhere else. Due to its slow spin and its fast oval-shaped orbit, the sun actually appears to rise, stop in the sky, move backwards for a short time, and then continue on its path. This happens because at one point in its orbit, the planet is moving around the sun faster than it is spinning. It is a moment of cosmic hesitation, a brief, silent pause in the heavens. For a moment, the morning on Mercury reverses itself. The shadows that were slowly stretching out begin to shorten again before they continue their long, slow journey across the landscape. A celestial stutter, a quiet moment of indecision in the sky. Because of this slow turn, the sun seems to move across the sky with incredible slowness. If you were standing on the surface, you could walk at a gentle pace and keep the sun forever on the horizon. You could live in a permanent sunset, a world of endless twilight, just by taking a slow, steady walk across the dusty ground. The sun would hang there, a brilliant, silent fire, never rising fully, never setting completely. The speed you would need to walk is only about 2 miles per hour, a gentle stroll to keep the day from ever truly beginning, a world held in a state of perpetual golden twilight. The surface of Mercury is wrinkled, like the skin of a dried fruit left in the sun for ages. These wrinkles are enormous cliffs, some stretching for hundreds of miles and towering over a mile high. They are not mountains pushed up from below, but wrinkles formed as the entire planet cooled and shrank long ago. Imagine a world that was once larger, and as its molten iron heart cooled and solidified, its surface buckled and folded in on itself. These cliffs, called Lobat scarps, are the quiet evidence of a planet settling into its final, smaller form, a slow geological sigh of relief that took place over millions of years, a quiet memory of a world that once was bigger. Mercury holds a secret of extreme temperatures, a world of fire and ice existing side by side. During its long day, with the sun hanging overhead for months, the surface temperature can soar to over 400 degrees Celsius, hot enough to melt lead. But during the equally long night, with no atmosphere to hold the heat, the temperature plummets to a staggering minus 180 degrees Celsius. It is a world of violent contrasts, a place that roasts and freezes in a slow, silent rhythm. The very same rock that was glowing with heat will later become so cold it is brittle as glass, a landscape that breathes fire and then exhales a deep cosmic cold. Even though it is small and seems inactive, Mercury has a faint magnetic field. This field is like a gentle, invisible bubble, a quiet shield protecting the planet from the harsh wind of the sun. It is a whisper of energy, created by a still-churning liquid outer core deep inside the planet. This field is not strong like Earth's. It is only about 1% as powerful, but it is there, a subtle sign of life in the planet's deep interior. It pushes back against the constant stream of particles from the sun, creating a small, calm space around the planet, a tiny, protected harbor in the vast, energetic ocean of the solar system, a secret strength held within a small, rocky heart. In the deepest shadows of Mercury's craters, there is a secret kept from the sun. Near the planet's north and south poles, the floors of some craters are so deep and so perfectly placed that they are never touched by sunlight. They are pockets of permanent night, places of extreme and unending cold. In these eternal shadows, scientists have discovered something surprising: water ice. For billions of years, this ice has survived, likely delivered by crashing comets and asteroids long ago, protected from the nearby sun by the darkness of a crater wall. It is a quiet reservoir of frozen water, sleeping in a place where the sun has never shone. Ancient ice, preserved in eternal shade. Mercury has a ghost of an atmosphere, a thin veil called an exosphere. It is not an atmosphere you could breathe. It is a near-perfect vacuum, with atoms so far apart they rarely collide. These atoms of sodium and potassium are blasted off the planet's surface by the solar wind and micrometeorites. They form a very faint, glowing tail that streams away from the planet, a tail you cannot see with your eyes. It is the planet's own dust, slowly leaking into space, a silent, invisible plume stretching for millions of miles behind a sleeping world. Next, we drift outward to the planet Venus, a world completely shrouded in cloud. The clouds of Venus are thick and heavy, and they move with a slow, majestic grace. They are not made of water like Earth's clouds, but are composed of tiny droplets of sulfuric acid, giving the planet its soft, pale yellow glow. This permanent global layer of cloud hides the surface completely, making Venus a world of secrets. From space, it looks peaceful, serene, a smooth, featureless pearl. But this veil conceals a world of extreme heat and pressure, a beautiful mask, hiding a harsh and quiet truth. Venus spins in a way that is unique among the major planets. It spins backwards. While Earth and most other planets spin counterclockwise, Venus turns in a slow, clockwise direction. This is called retrograde rotation. Its spin is also the slowest in the entire solar system. A single day on Venus, the time it takes to turn once, is 243 Earth days long. This is even longer than its year, which is only 225 Earth days. It is a world turning in a slow, contrary dance, a gentle rebellion against the common motion of the cosmos, a planet that takes its time, moving to its own silent, backward rhythm. On the highest mountains of Venus, there is a strange and beautiful phenomenon. It appears as if the mountain peaks are dusted with a metallic frost, a sort of cosmic snow, but it is far too hot for water ice to exist. This snow is actually made of heavy metals, likely lead sulfide and bismuth sulfide. These metals are vaporized in the intense heat of the lowlands, rise up in the thick atmosphere, and then condense and fall like snow on the cooler, higher altitudes of the mountains, like Maxwell Montes. It is a slow, silent snowfall of glittering metal, coating the highest peaks in a thin, reflective layer, a quiet, metallic dusting on the mountaintops of a hidden world. Because of its incredibly thick atmosphere, the heat on Venus is spread almost perfectly across the entire planet. The dense blanket of carbon dioxide gas traps the sun's warmth, creating an extreme greenhouse effect. This means there is almost no difference in temperature between the day side and the night side, or between the equator and the poles. The entire world is held in a constant, heavy warmth of over 460 degrees Celsius. It is a planet without seasons, without cold nights, a world wrapped in a single, thick and profoundly warm blanket, a place of constant, sweltering stillness. The pressure on the surface of Venus is immense, a quiet, crushing weight. The atmosphere is so thick and heavy that standing on the surface would feel like being almost a kilometer deep in the Earth's ocean. The pressure is more than 90 times that of Earth's at sea level. This heavy, crushing stillness affects everything. Any sound would travel slowly, muffled by the dense air, which is like a thick soup. The light from the sun is scattered and diffused, creating a dim, hazy, orange-lit world under a perpetual overcast sky, a place where the very air has weight, a deep and powerful quiet born of immense pressure, a world of deep, silent compression. The surface of Venus is surprisingly young in geological terms. While other rocky worlds are covered in ancient craters, the surface of Venus seems to have been wiped clean. Scientists believe that roughly 500 million years ago, a massive planet-wide volcanic event took place. Lava flowed everywhere, burying the old craters and reshaping the entire world. This may have happened because Venus lacks plate tectonics, so heat from its core builds up for hundreds of millions of years until it bursts out all at once. This means the landscape we imagine under the clouds is not ancient, but is a newer, smoother version of the planet, a world that gave itself a new face in a fiery, silent rebirth. For a planet so similar in size to Earth, Venus has a strange and quiet absence. It has no magnetic field to speak of. While Earth's churning liquid core creates a powerful shield, the heart of Venus is strangely still. This might be because its rotation is too slow to stir the core, or because its inner core has completely solidified. Without this magnetic protection, the sun's solar wind strikes the upper atmosphere directly, slowly stripping away gases like water vapor into space over billions of years, a beautiful world left without a shield. Under the thick clouds, the surface of Venus is dotted with volcanoes, more than any other planet in our solar system. There are over 1,600 major volcanoes and potentially hundreds of thousands of smaller ones. While many are long dormant, there is evidence that some may still be active. Recent observations have shown changing levels of sulfur dioxide in the atmosphere and hotspots on the surface that glow and fade, like the embers of a recent eruption. It suggests that deep beneath the crushing air, the planet is still quietly breathing fire, a silent volcanic pulse, hidden beneath a veil of acid clouds. We continue our journey and see a familiar blue marble ahead, our own planet, Earth. From far away in the darkness of space, our world is a picture of life and motion. It is mostly deep blue ocean, swirled with veils of pure white cloud, dotted with the greens and browns of land. At night, the continents glitter with the soft lights of cities. It is a living, breathing planet, a vibrant oasis in the vastness of space. Seeing it from a distance gives a sense of peace, a feeling of connection to this beautiful, fragile home we all share. It is a quiet reminder of the preciousness of our world, a pale blue dot floating in a sunbeam. Our planet hums with a quiet, unheard energy, a deep and steady vibration. This is the sound of its magnetic field, a phenomenon you cannot hear with your ears, but that can be detected by sensitive instruments. It is a very low-frequency sound, a deep bass note created by the constant slow churning of liquid iron in the Earth's outer core. This motion creates a powerful magnetic field that protects us, a shield against the solar wind. This silent hum is the sound of our planet's heart, a steady, rhythmic pulse that has been beating for billions of years, the silent heartbeat of our own world. The Earth is gently tilted on its axis, a lean of about 23.5 degrees relative to its path around the Sun. This simple tilt is the reason we have seasons. It is not because we are closer or farther from the Sun, but because of the angle of the light. As our planet journeys on its year-long orbit, different parts of the globe are tilted toward the Sun, receiving more direct, concentrated light. This leads to the slow, soft, and beautiful changes from spring to summer to autumn and to winter. It is a slow, rhythmic nod, a gentle lean that brings the seasons and all of life into being. Long ago, our Earth did not have a moon. Then, a great and silent event occurred, a planet-sized object about the size of Mars, which scientists call Theia, collided with the young Earth. The impact was immense, but it happened in the perfect silence of space. A huge cloud of vaporized rock and debris was thrown into orbit around our planet. Over time, gravity slowly pulled all of this material together. The dust became pebbles, the pebbles became rocks, and the rocks gathered into the sphere we now know as the Moon. It was born from a collision, a chaotic moment that settled into a perfect, quiet partnership, a companion forged in fire and silence. Our moon has a profound and calming effect on the Earth. It acts as a silent guardian in the sky. Its gravitational pull is a steadying hand, keeping our planet's wobble from becoming too wild or unpredictable. Without the moon, the Earth's tilt could shift dramatically over long periods, leading to extreme and chaotic changes in our climate that would make complex life very difficult. The moon stabilizes our world, ensuring that our seasons and our climate remain relatively gentle and predictable over millions of years. It is a quiet anchor, a steady hand on a spinning top that allows life to flourish in a stable home. The continents on Earth are not fixed in place. They are on a slow, silent journey. They are drifting across the surface of the planet, moving only a few centimeters each year, about the same speed that your fingernails grow. This movement, called plate tectonics, is driven by the slow circulation of rock in the Earth's mantle beneath them. It is a motion so slow, it is almost impossible to perceive. Over hundreds of millions of years, this gentle drift creates mountains, opens oceans, and completely reshapes the face of our world, forming and breaking apart supercontinents like Pangaea, a form of deep geological patience, a slow dance of land across the face of the Earth. Beneath the blue surface of our world lies another world of deep quiet and mystery. Earth's oceans are so vast and so deep that most of this realm has never been seen by human eyes. In the crushing blackness of the deepest trenches, in the Hadal zone, where no sunlight can reach, life still exists. Strange, ghostly creatures drift in the cold water, living off chemical energy from volcanic vents on the seafloor. It is a world without light, where the pressure is over 1,000 times greater than at the surface. A silent, hidden kingdom within our own planet, a place of deep peace and profound mystery. Deep within the Earth's crust, far below our feet, there exists a hidden realm of life. This is the deep biosphere, a world of microscopic organisms living in the tiny pores of solid rock, miles beneath the surface. They do not depend on sunlight or air. They live on chemical energy from the rocks themselves, and their metabolism is incredibly slow. Some of these microbes may live for thousands of years, their life unfolding at a geological pace. It is a silent, hidden world of life, a slow-motion kingdom buried deep within the warm stone of our own planet. When astronauts walked on the moon, they brought back samples of its fine, dark dust. They also brought back a strange memory, a distinct smell. In the vacuum of space, the dust had no smell, but when it was brought inside the lunar module and mixed with air, the astronauts reported a sharp, distinct scent, like spent gunpowder or wet ash in a fireplace. This smell is thought to come from the way the solar wind has bombarded the lunar soil for billions of years, creating reactive, activated particles that interact with the air. It is the faint, ancient scent of another world, the quiet smell of gunpowder after a 4-billion-year-long silent explosion. Our moon is not a dead and silent world. It is still quietly active. It experiences moonquakes, tremors that shake its surface. Some are caused by the slow cooling and shrinking of its core, which causes the crust to wrinkle and crack. Others are caused by the immense gravitational pull of the Earth, which gently squeezes and stretches the moon as it orbits. There are even thermal quakes, as the crust rapidly expands and contracts when it moves from the freezing lunar night into the bright, hot sunlight. These are quiet shudders, faint vibrations in the ancient rock, the soft, sleeping sighs of a world we think of as still. The dark patches on the moon that create the man in the moon are not shadows. They are vast, flat plains of dark volcanic rock called Maria, which is Latin for seas. Long ago, huge asteroids struck the moon, creating massive basins. Molten rock from the moon's interior then welled up and filled these basins, creating smooth, dark surfaces. They are ancient, solidified lakes of lava, frozen oceans of dark rock. They are mostly found on the side of the moon that faces us, the near side, giving it a very different appearance from its other half, a story of a time when the moon had a fiery, molten heart. The side of the moon that always faces away from us is called the far side. For all of human history, it was a complete mystery. It is a very different world from the near side we see. It has almost none of the dark, volcanic Maria. Instead, it is a landscape of pale, rugged highlands, almost completely covered in craters of all sizes. It is a more ancient and battered face, a quiet testament to the heavy bombardment of the early solar system. It is the moon's secret face, a silent, pockmarked landscape, forever turned away from our view. Now we travel onward to the fourth planet from the sun, the quiet, red world of Mars. The sky on Mars is not blue like ours. It is a soft, gentle butterscotch or pale pink color. This is because its thin atmosphere is filled with fine particles of reddish dust, kicked up from the surface by gentle winds. This dust scatters the sunlight differently, creating a warm, hazy sky. But at sunset, something beautiful happens. The area around the setting sun glows with a faint, ethereal blue light. This is because the dust scatters the blue light forward, towards the observer, creating the opposite of a sunset on Earth. A cool blue farewell to a sun that appears smaller and dimmer than our own. A dusty, gentle twilight on another world. Because the atmosphere on Mars is so thin, only about 1% as dense as Earth's, sound would travel very differently there. It would be much quieter. A shout on Mars would sound like a whisper on Earth. The sound would also travel more slowly, and higher-pitched sounds would not travel as far as lower-pitched sounds, fading away quickly. It would be a muffled, strange soundscape. A conversation would be difficult, with words fading quickly into the thin, cold air. It is a world where sound itself is diminished, where silence is the natural state, a place of quiet, where even a storm would whisper. Mars is home to the largest volcano in the entire solar system, a gentle giant named Olympus Mons. It is a shield volcano, meaning it was built up slowly over time by very fluid lava flows. It is so wide, wider than the entire state of Arizona, and its slopes are so gentle that if you were standing on its edge, its peak would be over the horizon. You could not even see that you were on a mountain. It is 3 times taller than Mount Everest, a mountain that touches the edge of space. It has been silent for millions of years, its last eruption a distant memory, a sleeping giant deep in a planet-wide slumber. Mars has seasons, just like Earth, because it too is tilted on its axis. But the seasons on Mars last about twice as long, because a Martian year is nearly 2 Earth years long. These long, slow seasons have a visible effect on the planet. The polar ice caps, made of both water ice and frozen carbon dioxide, grow much larger in the long, cold winter, and then shrink and retreat in the gentle summer. You can watch the planet slowly breathe, the white of the poles advancing and receding in a slow, silent rhythm, marking the patient passage of a distant year. The 2 moons of Mars, Phobos and Deimos, are not like our large, round moon. They are very small, lumpy, and shaped like potatoes. They are most likely asteroids, captured by Mars's gravity long ago. They orbit the red planet quietly, like 2 small dark stones tossed into a slow, circular path. Phobos orbits so close and so fast that it rises and sets twice in a single Martian day. But its orbit is slowly decaying. In tens of millions of years, it will either crash into Mars or be torn apart to form a faint ring, a silent, irregular companion, with a slow but certain doom. Long ago, the surface of Mars was a very different place. There is clear and abundant evidence that liquid water once flowed freely. We can see the graceful curves of dry riverbeds, the fan-shaped patterns of ancient deltas where rivers met lakes, and minerals like gypsum and hematite blueberries that could only have formed in the presence of water. The water is gone now, most of it lost to space as Mars lost its atmosphere, some of it frozen beneath the surface as permafrost. But the memory of that water remains, beautifully and silently carved into the planet's rusty red surface, the ghost of a river flowing through a desert of red dust. Across the red planet, another giant feature sleeps in silence. It is a vast network of canyons called Valles Marineris. It is not just one canyon, but a huge system that stretches for a distance equal to the width of the entire United States. If it were on Earth, it would span from coast to coast. It is far deeper and longer than our Grand Canyon. It is a great silent scar on the face of Mars, likely formed not by a river, but by the planet's crust stretching and cracking apart long ago, a quiet wound from the planet's distant youth. The quiet surface of Mars is not entirely still. It has its own gentle weather. Small, swirling columns of wind, called dust devils, silently roam the plains. They are like small, dusty tornadoes, but they are formed by rising warm air on a calm day. They dance across the landscape, lifting the fine red dust into the thin air, drawing silent patterns on the ground. These gentle whirlwinds have a surprising benefit. They have occasionally cleaned the solar panels of our robotic rovers, giving them a new lease on life. The ghosts of the Martian wind, wandering the empty deserts without a sound. The polar caps of Mars are not just simple sheets of ice. They are layered records of the planet's history. These caps are made of a mix of water ice and frozen carbon dioxide, or dry ice. In the summer, the dry ice turns to gas, revealing the permanent water ice cap underneath. These polar layered deposits contain fine bands of ice and dust, stacked on top of each other like the pages of a book. Each layer tells a story about the Martian climate of the past, a silent archive holding the memory of ancient seasons. Beyond Mars lies a vast, quiet space, a region known as the asteroid belt. It is not a crowded, chaotic field of rocks as it is often imagined in movies. Instead, the asteroids are incredibly far apart from each other. The average distance between them is hundreds of thousands of miles. If you were on one asteroid, you would likely not even be able to see the next one with your own eyes. They are lonely islands of rock and metal, ancient remnants from the formation of the solar system, drifting in a slow, predictable, and very empty path around the sun. A sparse river of ancient rubble, flowing silently in the dark. Within this quiet belt, there is a dwarf planet named Ceres. It is the largest object in the asteroid belt, a small, spherical world of rock and ice. Its surface is dark and cratered, but it holds a beautiful secret. In some of its craters, there are incredibly bright spots that shine in the dim light. Scientists have discovered that these are deposits of salt, likely left behind as salty water from beneath the surface seeped out in a form of cryovolcanism, and then sublimated into space, leaving the bright white salt behind, a quiet, glittering tear on the face of a tiny world. Also in the belt is Vesta, which is not a dwarf planet, but a giant asteroid that is almost one. It is like a tiny, frozen planet, with its own iron core, a rocky mantle, and a crust. It is a protoplanet, a planetary embryo that was stopped from growing bigger by the immense gravity of nearby Jupiter. It is a survivor from the dawn of the solar system, a perfectly preserved building block of a world that never was, a quiet, rocky memory of what might have been. And now we approach the king of planets, the immense and beautiful giant, Jupiter. This giant world also has rings, but they are faint, dark, and difficult to see. Unlike Saturn's bright, icy rings, Jupiter's are made of tiny, dark dust particles. They are almost invisible, a secret halo around the giant planet. They are best seen when you are in Jupiter's shadow, looking back toward the sun. The sunlight filters through the dust, making the rings glow faintly. They are formed from dust kicked up by tiny meteoroids hitting Jupiter's small inner moons, a whisper of a ring made of stardust and shadow. The most famous feature on Jupiter is the Great Red Spot. It is a colossal storm a swirling anticyclone wider than our entire planet Earth. It has been observed for hundreds of years, a permanent hurricane of deep red and orange clouds. But here, in the vacuum of space, this immense and powerful storm is completely silent. There is no air to carry the sound of its ferocious winds. It is a silent tempest, a slow, majestic, swirling dance of colorful gases, a storm that has been raging for centuries without making a single sound. Deep within Jupiter's thick atmosphere, the pressure becomes so immense that it changes the very nature of matter. The hydrogen gas, which makes up most of the planet, is squeezed so tightly that it becomes a liquid. Deeper still, the pressure is so great that the liquid hydrogen begins to act like a metal. It can conduct electricity. This vast, planet-sized ocean of liquid metallic hydrogen is what generates Jupiter's incredibly powerful magnetic field. It is a hidden ocean, not of water, but of a strange, exotic metal, churning slowly in the deep, dark heart of the planet, a quiet engine of immense power. Jupiter is like a star in its own right, with a family of dozens of moons, a miniature solar system. The four largest, Io, Europa, Ganymede, and Callisto, are called the Galilean moons. They were discovered long ago by Galileo, and they changed our understanding of the universe. They orbit Jupiter in a perfect rhythmic dance, a state called orbital resonance. For every one orbit of Ganymede, Europa makes 2 orbits, and Io makes 4. It is a beautiful, predictable, and stable pattern, a clockwork of worlds, ticking silently in the deep of night. One of these moons, Europa, holds a tantalizing secret beneath its surface. Its face is a smooth, bright shell of water ice, crisscrossed with long, dark cracks and streaks. But scientific evidence strongly suggests that beneath this icy shell, there is a vast global ocean of liquid salt water. This hidden ocean may contain more water than all of Earth's oceans combined. It is kept liquid not by the sun, but by the heat generated from the constant stretching and pulling of Jupiter's immense gravity. It is a dark, cold ocean, a silent, hidden sea, holding the deep quiet of an entire world. Another of Jupiter's great moons, Ganymede, is a true giant. It is the largest moon in the entire solar system, even larger than the planet Mercury. It is a world of rock and ice, with a surface that shows 2 different types of terrain. There are dark, ancient, heavily cratered regions, and younger, lighter regions with grooves and ridges. Uniquely for a moon, Ganymede has its own magnetic field, generated by a liquid iron core deep inside. It is a quiet world, but one with a dynamic history and a gentle, magnetic soul. A giant moon with its own faint, protective heartbeat. And then there is Io, a world of fire and brimstone, constantly in turmoil. It is the most volcanically active body in the solar system. Its surface is a chaotic canvas of yellow, red, orange, and black, painted by sulfur compounds from its hundreds of active volcanoes. This intense activity is caused by the immense gravitational pull of Jupiter on one side and the other large moons on the other, constantly squeezing and heating the moon's interior like a piece of clay being worked in a giant hand. But its spectacular eruptions happen in a vacuum, so they are completely silent, vast plumes of sulfur and gas rising and falling in perfect, beautiful quiet. Silent fireworks in the shadow of a giant. The last of these 4 great moons is Callisto, a world that seems to be in a deep sleep. Its surface is the oldest and most heavily cratered in the solar system. It is a dark, icy world that has not changed much in over 4 billion years. There are no large mountains or volcanoes, no signs of geological activity. It is a quiet museum of the solar system's history. Each crater a scar, a memory of a long-ago impact from the early days. It hangs in space, a still and silent face, turned forever toward the stars, a perfect record of the passage of time. Jupiter's immense size and gravity play a crucial role in our solar system. It acts as a cosmic guardian. Its powerful gravitational pull acts like a giant slingshot or a catcher's mitt for comets and asteroids that drift in from the outer solar system. It pulls them in to collide with itself, as seen with comet Shoemaker Levy 9, or it flings them out of the solar system entirely. It is a silent protector, a cosmic shepherd, that has likely shielded Earth and the other inner planets from countless impacts over billions of years, a gentle giant, keeping a quiet watch over its smaller family. The giant planet is also home to the most powerful auroras in the solar system. These are shimmering curtains of light, far brighter and larger than our own northern lights. They are created as charged particles, guided by the planet's immense magnetic field, slam into the atmosphere near the poles. But these are not just created by the solar wind. Jupiter's volcanic moon Io also spews particles into space, which are then captured by Jupiter's gravity and funneled into these spectacular silent light shows, a dance of light, powered by both a star and a moon. We drift further now, into the colder, dimmer reaches of space, to the jewel of the solar system, Saturn. The planet itself is a beautiful, pale, butter-yellow giant. It is the least dense of all the planets. It is so light, made mostly of hydrogen and helium, that if you could find a bathtub or an ocean large enough to hold it, Saturn would float. It is a world of gas and air, a giant sphere that spins so fast it bulges at its equator and flattens at its poles, a world as light as a cloud, a world that could bob gently on an imaginary cosmic sea. Saturn's rings are its most breathtaking and iconic feature, a wide, flat disk of shimmering ice and rock. From a distance, they look solid and smooth, but they are actually made of countless individual particles. These particles range in size from tiny specks of dust to chunks as large as a house, all orbiting the planet together. They are made almost entirely of pure water ice, making them incredibly bright and reflective. They form a silent, glittering river of ice, a billion tiny moons, all dancing in a perfect circle of light. For all their vastness, stretching tens of thousands of miles across, the rings of Saturn are incredibly thin. In most places, they are only about 10 to 30 feet thick. If you were to create a scale model of the rings the size of a large football field, they would be thinner than a single sheet of paper. They are a delicate, almost two-dimensional structure, a vast, flat plane of shimmering, weightless ice. This thinness is why they seem to disappear when we view them edge-on from Earth, a cosmic sheet of paper, written with the light of the sun. Within the beautiful, complex structure of the rings, there are dark, empty gaps. The most famous is the Cassini division, a wide, dark gap that separates the two brightest rings. This gap is not completely empty, but it contains far fewer particles. It is kept clear by the gravitational pull of the moon Mimas, which orbits further out. Its gravity gently nudges any particles in the gap, pulling on them at the same point in their orbit over and over, pushing them into different orbits over millions of years. A silent, invisible gardener, weeding a cosmic path. Some of these gaps are kept clear by the gravitational influence of tiny moons, called shepherd moons. These small moons orbit just inside or outside a ring, or even within a gap, and their gravity gently nudges the ring particles, herding them into place and preventing them from spreading out. Moons like Pan and Daphnis orbit within the rings themselves, carving out perfect, clean gaps and creating beautiful, wavy ripples at the ring edges. They act like tiny cosmic gardeners, carefully tending the edges of the rings, silent shepherds, guiding a flock of ice. A strange and fleeting phenomenon can sometimes be seen in Saturn's rings. Dark, radial patterns called spokes. These are temporary features that can form and then disappear in just a few hours. They rotate along with the rings, but they are not made of matter. Scientists believe they are clouds of tiny, electrically charged dust particles, levitating just above the main ring plane due to the planet's magnetic field. They are like faint shadows or smudges, appearing and vanishing without a sound, ghostly patterns haunting the glittering rings. On Saturn's north pole, there is a strange and beautiful pattern in the clouds. A persistent and near-perfect hexagon. It is a six-sided jet stream, a weather pattern wider than two Earths. It does not move or change its shape. It just spins slowly in place, a fixed and stable feature in a dynamic, gaseous world. We do not see such a thing on any other planet. It is a mysterious and beautiful piece of natural geometry, a vortex that has remained stable for decades, drawn in the clouds of a distant world, a perfect shape, created by the silent flow of wind. One of Saturn's most fascinating moons is Titan, a world shrouded in a thick, golden-orange haze. It is the only moon in our solar system with a substantial atmosphere, one that is even denser than Earth's. The air is so thick, and the gravity on Titan is so low, that if you were there, and you had small wings attached to your arms, you could actually fly by simply flapping them. You could soar like a bird through a cold, silent golden sky, a world where you could drift on the wind, over a landscape hidden in mist. The surface of Titan is a strange reflection of Earth, with rivers, lakes, and even vast seas. But on this incredibly cold world, they are not filled with water. They are made of liquid methane and ethane, hydrocarbons that are gases on Earth, but liquids in Titan's frigid climate. It rains methane there, a slow, cold drizzle from an orange sky that carves river channels and fills the great northern lakes. The Huygens probe landed on a damp plain of ice pebbles, a quiet alien water cycle, a gentle rain, on the shores of a methane sea. The seasons on Titan are long and slow, as Saturn takes nearly 30 Earth years to orbit the Sun. Each season on Titan lasts for about 7 Earth years. During these long seasons, vast clouds of methane form, drift across the planet, and create massive rainstorms. These storms, which can last for weeks, cause the methane rivers to swell and the lakes to fill. Strange, bright features called magic islands have been seen to appear and disappear in the lakes. Perhaps they are fields of bubbles rising from the depths, a weather cycle that unfolds over decades in the deep, cold quiet of the outer solar system. Another of Saturn's moons, Enceladus, is a small, bright white world, one of the most reflective objects in the solar system. It is covered in a shell of clean, fresh ice from long cracks in its southern polar region, which are nicknamed tiger stripes. Huge plumes of water vapor and ice particles erupt continuously into space, These plumes shoot hundreds of miles high, and they are the source of one of Saturn's faint outer rings, the E-ring. This tiny moon is breathing out a constant mist of ice, a silent, cold geyser, feeding a ring around its parent planet. There is a strange tumbling moon of Saturn called Hyperion, which looks like a giant porous sponge. It is covered in deep, sharp-edged, cup-like craters, giving it a bizarre and unique appearance. Unlike most moons, it does not have a regular, stable spin. It tumbles chaotically as it orbits Saturn, with no predictable axis or rotation speed. Its day length and its north pole change constantly. Its low density means that impacts tend to compress the surface rather than blasting out craters. A slow, tumbling, battered stone, a cosmic wanderer, captured in a dance it cannot control. And there is Mimas, a small inner moon of Saturn with a single defining feature. It is dominated by a very large impact crater named Herschel, which is almost a third of the moon's entire diameter. This massive crater gives the moon a striking resemblance to a famous science fiction space station. But it is just a quiet, pockmarked ball of ice, its appearance a cosmic coincidence. The impact that created the crater was so large, it likely came very close to shattering the little moon completely. A silent sphere, marked by a single giant unblinking eye. Farther out from Saturn, there is a moon of two faces, called Iapetus. One side of this moon is as bright as snow, while the other side is as dark as coal. As it orbits, it shows first its bright face, then its dark one. Scientists believe the dark material is dust, swept up by the moon as it moves through a faint, dusty ring created by another, more distant moon, Phoebe. The bright side is the moon's original icy surface. It is a world painted in perfect contrast, a quiet, slow spin, revealing a face of darkness, and then a face of light. One of Saturn's more quiet moons is Rhea, a heavily cratered ball of ice. For a time, scientists thought this simple moon held a great secret, a faint ring system of its own. This would have been the first discovery of rings around a moon. But further observation showed that the rings were not there. It was a ghost in the data. A beautiful idea that faded with a closer look. Rhea continues its silent orbit, a simple icy world. A quiet reminder that sometimes the universe is simpler than we imagine. A moon that dreamed it had a ring. Our journey takes us even further into the cold and the dark, to the seventh planet, Uranus. This planet is unique among all others. It is tilted completely on its side. Its axis of rotation is tilted by about 98 degrees, so it essentially rolls through its orbit like a ball. For long parts of its 84-year orbit, one pole faces the sun continuously for 21 years, while the other pole is plunged into a 21-year-long winter of total darkness. It is a world of extreme seasons, a lazy, sideways roll through the slow lane of the solar system. Uranus is a beautiful, pale, cyan blue color, a soft and featureless globe from a distance. This serene color comes from the small amount of methane gas in its hydrogen and helium atmosphere. The methane gas is very good at absorbing red light from the sun and reflecting the blue and green light back into space. It is a cold, quiet color, the color of a distant, frozen tropical sea. There are no swirling bands or giant storms visible, just a uniform, peaceful shade of blue, a world painted in a single, tranquil hue. The atmosphere of Uranus is the coldest of all the planets in our solar system. Temperatures in its upper cloud tops can drop to minus 224 degrees Celsius. It is a place of extreme, quiet, and profound cold. The planet actually gives off less heat than it receives from the sun, for reasons we do not fully understand. It seems to have lost most of its primordial heat from its formation. There are likely clouds of frozen methane, and perhaps deeper, unseen clouds of water, ice, and ammonia, all suspended in a deep, still, and frigid atmosphere, a place of deep and silent cold. Deep within the atmospheres of the ice giants, Uranus and Neptune, a strange and beautiful phenomenon may be happening. The immense pressure and high temperatures can break down methane molecules, releasing the carbon atoms. These carbon atoms then fall through the dense atmosphere, and the incredible pressure squeezes them together, forming solid diamonds. Scientists believe it may be raining diamonds deep inside these planets. These diamonds would then fall slowly through the slushy, icy mantle, eventually settling around the core, a slow, silent rain of treasure in the heart of a giant planet. Like the other gas giants, Uranus has rings, but its rings are very different from Saturn's. They are very dark and very thin, made of material as dark as charcoal or coal dust. They were not discovered by being seen directly, but by accident, when they passed in front of a distant star. As Uranus moved, the star blinked on and off several times before and after the planet passed by, revealing the presence of these dark, invisible rings. They are narrow and sharp-edged, perhaps shepherded by tiny, unseen moons, a secret set of rings hiding in the night. One of Uranus's moons, Miranda, is one of the strangest-looking objects in the solar system. Its surface looks like it was shattered into pieces and then put back together haphazardly. It has huge canyons, some 12 times deeper than the Grand Canyon, strange grooved terrain called coronae, and giant cliffs all jumbled together in a chaotic patchwork. One theory is that a massive impact shattered the moon, and gravity slowly and imperfectly reassembled the pieces. It is a puzzle of a moon, a quiet collection of broken parts, a patchwork world assembled in the dark. The magnetic field of Uranus is very strange and very quiet. Unlike Earth's field, which is roughly aligned with its spin axis, the magnetic field of Uranus is tilted by nearly 60 degrees. It is also significantly offset from the planet's center. This means the magnetic field tumbles and wobbles chaotically as the planet rotates. It creates a lopsided magnetosphere that is sometimes open to the solar wind and sometimes closed. It is a strange, messy, and unpredictable shield, a quiet, flickering magnetic heartbeat. Now we reach the last of the giant planets, the deep, vivid blue world of Neptune. Neptune's color is a much richer, more vibrant sapphire blue than the pale cyan of Uranus. This is also due to methane in its atmosphere absorbing red light. But something else, an unknown component in its atmosphere, gives it this deep, striking hue. It is a jewel of the deepest blue, glowing faintly in the far darkness of the solar system. A final, beautiful beacon before the great emptiness beyond. Neptune is a world of extreme weather. It has the fastest winds in the solar system. These winds can reach speeds of over 2,000 kilometers per hour, faster than the speed of sound on Earth. They are driven not by the faint sunlight, but by the planet's own internal heat, which is stronger than that of Uranus. They whip the frozen methane clouds around the planet in great dark streaks, but this is a silent speed. In the thick, gaseous atmosphere, with no solid surface to rush over, These supersonic winds flow in utter silence. It is a silent hurricane on a world of endless twilight, a storm of unimaginable speed, making no sound at all. Neptune also has a set of faint, dark rings. Like those of Uranus, they are hard to see, but Neptune's rings have a peculiar feature. Some of the outer rings are not complete circles, but strange clumpy arcs. For a long time, scientists did not understand how these clumps could exist, as they should spread out evenly. It is now thought that the gravity of a small, unseen moon, Galatea, holds these clumps together, corralling the ring particles into these bright, dense arcs, broken rings, held in place by an invisible hand. When the Voyager 2 spacecraft flew by Neptune in 1989, it saw a huge, dark storm similar to Jupiter's Great Red Spot. It was named the Great Dark Spot, a storm system the size of Earth, with high, white, wispy clouds racing above it. It was a dramatic and mysterious feature, but years later, when the Hubble Space Telescope looked at Neptune, the spot had vanished completely. Other dark spots have appeared and disappeared since. They are transient, temporary storms, giant tempests that form, rage silently for a few years, and then simply fade away into the deep blue. Neptune's largest moon, Triton, is a strange and captivating world. It is one of the few large moons in the solar system that orbits its planet backwards, in a retrograde direction. This tells us that Triton was not formed with Neptune, but was a wandering object from the Kuiper Belt, captured by Neptune's gravity long ago. It is a world of frozen nitrogen, with a surface that looks like the skin of a cantaloupe. It is also geologically active, with dark geysers that erupt plumes of nitrogen gas and dark dust into its incredibly thin atmosphere, a cold moon, traveling the wrong way on a one-way street. The surface of Triton is one of the coldest places in the solar system, a frigid landscape of frozen nitrogen and water ice. One of its most distinctive features is a vast area known as the cantaloupe terrain. It is a region of oval-shaped depressions and intersecting ridges that looks remarkably like the skin of a melon. We don't know for sure how this terrain formed, but it may be the result of icy slush from the moon's interior rising and falling. A slow, convective process that has shaped the surface into this unique, repeating pattern, a strange, beautiful texture, carved in ice under a dim sun. While Triton is Neptune's largest moon, its moon Nereid is known for its strange path. Nereid has one of the most eccentric, or stretched out, orbits of any moon in the solar system. It swings very close to Neptune and then sweeps incredibly far away, taking almost a full Earth year to complete one orbit. This wild, lopsided path suggests that its orbit was disturbed long ago, perhaps during the violent capture of the giant moon Triton, which would have thrown the orbits of Neptune's original moons into chaos. A small moon on a long and lonely path. Close to Neptune lies a dark and lumpy moon named Proteus. It is the second largest of Neptune's moons, yet it is not spherical. It is a blocky, irregular shape, like a rough polyhedron. It is so large that it is right at the limit of what an object of its density can be, without gravity pulling it into a sphere. It is also one of the darkest objects in the solar system, reflecting only a tiny amount of the faint sunlight that reaches it. A dark, angular world, silently holding its jagged shape against the gentle pull of gravity. We now leave the main planets behind and drift into a vast, cold, and dark region of space, the Kuiper Belt. This is a huge donut-shaped ring of icy bodies, far beyond the orbit of Neptune. It is a distant reservoir of ancient material, remnants from the formation of our solar system. It is the home of dwarf planets and trillions of sleeping comets. These comets are balls of ice and dust, and sometimes the gravity of a passing star or planet will nudge one of them on a long journey toward the inner solar system, a distant field of ice at the edge of the sun's reach. Here, in this distant realm, we find Pluto, the most famous of the dwarf planets. For decades, it was our 9th planet, a faint, mysterious dot. When the New Horizons spacecraft flew by, it revealed a surprisingly complex and beautiful world. On its surface is a huge, smooth, heart-shaped glacier made of frozen nitrogen, methane, and carbon monoxide. This glacier, named Sputnik Planitia, is slowly churning and flowing in convection cells like a giant lava lamp made of ice, a sign of ongoing geological activity on this tiny, distant world. A love letter, written in ice on a world far from the sun. Pluto's journey around the sun is a long and lonely one, taking 248 Earth years to complete a single orbit. Its path is not a neat circle, but a long, stretched-out oval. For about 20 years of this long journey, its orbit actually brings it closer to the Sun than Neptune, making it temporarily the 8th planet. Its path is also highly tilted compared to the main planets. It is a slow, patient journey through the outer darkness, a path that crosses the orbit of a giant, and then swings far out into the cold and the void. Pluto has a very thin atmosphere, a delicate haze made mostly of nitrogen gas that hugs the surface. This atmosphere is not permanent. As Pluto moves along its long, oval-shaped orbit and gets farther from the Sun, the temperature drops so low that this thin air freezes and falls to the ground like a gentle snow. The world's sky literally disappears for a time, only to slowly return decades later as Pluto moves closer to the Sun again and the ice turns back into gas. It is a sky that falls asleep and dreams of being snow before waking up again. Pluto is not alone. It has a large companion. Its biggest moon, Charon, is so large compared to Pluto, about half its diameter, that they are sometimes called a double dwarf planet system. They orbit a point in space that is outside of Pluto itself. They are also tidally locked to each other, meaning they always show the same face to one another. If you stood on one side of Pluto, Charon would hang motionless in the sky, never rising or setting. They are frozen in a permanent silent gaze. Two worlds, locked in a slow, eternal dance. Beyond Pluto, there are other, smaller worlds drifting in the Kuiper Belt. Other dwarf planets like Eris, Makemake, and Haumea. Eris is actually slightly more massive than Pluto, and its discovery is what led to the reclassification of what it means to be a planet. Haumea is a strange oval-shaped world that spins incredibly fast, completing a day in just 4 hours, and it even has its own faint ring. We know very little about these distant objects. They are just faint points of light, moving with incredible slowness against the backdrop of distant stars. Quiet little worlds, sleeping at the edge of our solar system. Far beyond the main Kuiper Belt, there are objects on even stranger orbits. One such world is Sedna. It has a huge 11,000-year orbit that is so stretched out it never comes close to Neptune. Its great distance has led some astronomers to believe that its orbit was shaped by something massive and unseen, far out in the dark. Perhaps a 9th giant planet still waiting to be discovered. a quiet clue to a hidden giant in the dark. Far beyond even the Kuiper Belt lies a theoretical realm of unimaginable size, the Oort cloud. It is thought to be a vast spherical shell of icy objects, trillions of sleeping comets surrounding our entire solar system. It is the most distant part of our Sun's family, reaching almost a quarter of the way to the next nearest star. These comets drift in a slow, silent dance, barely held by the Sun's gravity. It is a great, dark sphere of ice, the final, quiet frontier of our solar system. Now, our journey takes us beyond the reach of our own Sun, into the vast galaxy at large. We are searching for exoplanets, planets that orbit other stars. For most of human history, we only guessed that they existed. Now we know of thousands. One of the main ways we find them is by watching a star's light very carefully. If a planet's orbit takes it directly in front of its star from our point of view, the star's light will dim by a tiny, almost imperceptible amount. This event is called a transit, a planet's shadow, falling across a star 1,000 light-years away. Another clever way we find these invisible worlds is by watching for a star's wobble. A large planet's gravity doesn't just pull on other planets, it also gently pulls on its parent star. This causes the star to wobble back and forth by a tiny amount as the planet orbits it. We can detect this wobble by seeing the star's light shift slightly towards the blue as it moves toward us, and then towards the red as it moves away. It is the sign of a silent partner, a world we cannot see, revealed only by its gentle rhythmic pull, a dance of gravity between a star and its invisible child. The Kepler Space Telescope was a quiet hunter of worlds. For years it stared at a single patch of sky, containing over 150,000 stars. It did not move, it just watched patiently for the tiny dip in brightness caused by a transiting planet. It was like watching a huge field of candles, waiting for one to flicker for just a moment. Through its patient vigil, Kepler discovered thousands of planet candidates, showing us that planets are not rare, but incredibly common in our galaxy, a silent watchman that opened our eyes to a universe full of worlds. Some of the first exoplanets ever discovered were a strange and surprising type, now called hot Jupiters. These are gas giants, similar in size to our own Jupiter, but they orbit extremely close to their parent stars, much closer than Mercury orbits our Sun. Their years can be just a few Earth days long. Because they are so close, they are tidally locked, with one side of the planet always facing the star in perpetual scorching day, and the other side facing away in a perpetual frozen night, a world of eternal sunrise and eternal sunset. On these hot Jupiter worlds, the weather is unlike anything in our solar system. The side facing the star is so hot that rocks can vaporize, forming clouds of silicate minerals. These clouds are then blown by ferocious winds to the cooler night side of the planet. There, the vaporized rock condenses and falls as rain. It could be raining liquid rock, or even molten iron or glass, on the dark side of these planets. It is a silent, exotic weather cycle, a slow, steady rain of liquid metal in the permanent twilight of a tidally locked world. There is another common type of planet in the galaxy, one we do not have in our own solar system. These are called super-Earths. They are rocky planets, like Earth or Mars, but they are significantly larger and more massive, up to 10 times the mass of our own world. We do not know for sure what these planets are like. Would they have thicker atmospheres, stronger gravity, deeper oceans? Some may be rocky and barren, while others could be water worlds, completely covered in a global ocean. A new kind of world, their nature a quiet, tantalizing mystery. A bigger, heavier Earth, orbiting a distant sun. Perhaps the most lonely worlds of all are the rogue planets. These planets do not orbit any star. They were likely formed in a solar system, but were then ejected by the gravitational pull of other larger planets. Now, they drift silently and alone through the vast, empty space between the stars. They are cold, dark, and on an endless journey through the galaxy. They are cosmic orphans, forever separated from the warmth and light of a parent star, on an endless, solitary journey through the deep dark. Even though they drift in the frozen darkness, it is possible that some rogue planets could harbor life. If a large, gas giant rogue planet has a large moon with a thick atmosphere, the gravitational pull of the planet could create tidal heating, warming the moon's core from the inside out. This could create a liquid water ocean beneath a shell of ice, similar to Europa. In this hidden, dark ocean, warmed by the planet's pull, life could potentially exist, a secret cradle of life, wandering the interstellar night. The space between stars is not completely empty. It is filled with vast, cold clouds of gas and dust. Within these nebulae, new planets are being born. A dense clump of material begins to collapse under its own gravity, pulling more and more gas and dust into a spinning disk. This is a protoplanetary disk, the cradle of new worlds. In the faint light of a newborn star at its center, the dust begins to glow, a spinning nursery where gas and dust dream of becoming planets. Within this spinning disk of material, the process of building a planet begins, and it is a slow and patient one. Tiny dust grains, smaller than smoke particles, gently bump into each other and stick together due to static electricity. Over thousands of years, they form pebbles. These pebbles then gather into rocks, the rocks into boulders, and eventually into objects miles across called planetesimals. This slow, quiet, and steady process of gathering material is called accretion, a world being built, one tiny speck of dust at a time. Over millions of years, a young planet carves out its own path in the disk. Its growing gravity allows it to dominate its orbital region. It either pulls in all the smaller debris, adding to its own mass, or its gravity flings the debris away into other parts of the solar system. This is a slow, quiet cleaning of its cosmic neighborhood, creating a stable, empty path for its long journey around its star. It is the final step in becoming a true planet, a planet tidying its home for the billions of years to come. The color of a planet tells a quiet story, a story written in light that travels across light years. A planet's color comes from the gases in its atmosphere, which absorb some colors of starlight and reflect others, and from the minerals on its solid surface. By analyzing the light from a planet, even a distant exoplanet, scientists can begin to guess what it is made of. It is a silent broadcast, a message painted in shades of blue, red, and yellow, telling us about the nature of a world we will never visit. The James Webb Space Telescope has a remarkable ability to read these stories. When an exoplanet passes in front of its star, some of the starlight filters through the planet's atmosphere. The telescope's incredibly sensitive instruments can analyze that light and see which colors have been absorbed by the gases in the atmosphere. This tells us what the air is made of, whether it has water vapor, or methane, or carbon dioxide. It is like discovering the ingredients of a world's breath from 1 billion miles away. Deep inside every planet, there is a core. This is the result of a process called differentiation, where heavier materials sink to the center of a young molten planet. Some cores are solid iron, like Earth's inner core. Others are molten liquid, like Earth's outer core. And in the ice giants, the core may be a rocky center surrounded by strange, compressed ices. The core is the planet's quiet engine, the source of its internal heat, and the generator of its protective magnetic field. A warm heart, hidden deep beneath layers of rock and gas. Every planet has a day, the time it takes to spin once on its axis, and every planet has a year, the time it takes to complete one orbit of its sun. Each world has its own unique rhythm, its own measure of time. From Venus's day that is longer than its year, to Jupiter's day that is less than 10 hours long. Each planet moves to its own internal and external clock, a slow cosmic timepiece, ticking at the heart of every world. Gravity is the gentle, silent force that shapes the universe of planets. It is not a push or a pull in the way we usually think. Einstein described it as a curve in the very fabric of space and time. A massive object like a star creates a deep curve, like a heavy ball on a rubber sheet. Planets are not being pulled. They are simply following the straightest possible path through this curved space. They are like marbles rolling in a great invisible bowl, guided by a silent, unseen hand in a dance that lasts for eons. The space between the planets is a near-perfect vacuum, a place of profound and absolute silence. There is no air, no medium to carry sound waves. All of the motion, all the grand orbits, the fast spins, the violent storms, and the volcanic eruptions happen in a state of complete and utter quiet. The entire solar system, the entire universe, is a silent movie, playing on the vast, dark screen of the night sky. Sometimes, on a very clear, dark night, far from city lights, you can see a faint, ghostly pyramid of light in the sky after sunset or before dawn. This is the zodiacal light. It is not from a distant galaxy. It is sunlight reflecting off the dust within our own solar system. A vast, flat cloud of tiny dust particles, left over from comets and asteroid collisions, orbits the sun in the same plane as the planets. This faint glow is the light of our own sun, illuminating the quiet dust between the worlds. There is another faint light you can sometimes see, a gentle glow on the dark part of our own crescent moon. This is called planet shine, or more commonly, earth shine. It is the light of the sun, reflecting off the clouds and oceans of the earth, traveling to the moon, and then reflecting back to our eyes. It is the light of our own world, softly illuminating the moon's night side. When you see this, you are seeing the beauty of our own planet, painted gently on the face of the moon, the Earth's light, giving the moon a soft, ghostly glow. Some planets are called gas giants, like Jupiter and Saturn. They are made almost entirely of hydrogen and helium. These planets do not have a solid surface that you could stand on. If you were to descend into their atmosphere, it would just get thicker and denser and hotter. Eventually, the gas would become so compressed that it would transition into a strange liquid, and then into a liquid metal deep inside. It is a world with no ground, just an endless falling through layers of cloud into a deep, dark, and heavy heart. Other giants, like Uranus and Neptune, are called ice giants. They are different from the gas giants. While they also have hydrogen and helium atmospheres, they are made of heavier materials underneath. These are compounds like water, methane, and ammonia, which astronomers call ices, even though they are likely in a hot, dense, fluid state inside the planet. These are slushy, half-frozen worlds, deep beneath their cold, cloudy tops, like giant cosmic slushies drifting at the very edge of the solar system. There are planets that orbit two stars at once, called circumbinary planets. From the surface of such a world, you would see two suns in the sky. Depending on their orbits, they might rise and set together, or one might rise as the other sets. The days would have complex and beautiful patterns of light and shadow. Imagine a double sunset, painting the clouds in twice the color, a sky with two suns, creating a world of shifting light and warmth. Even stranger are the pulsar planets. These worlds orbit the dead, spinning remnant of a massive star, a tiny, incredibly dense object called a pulsar. A pulsar flashes a beam of radiation like a lighthouse, spinning around many times a second. These flashes are incredibly regular. By measuring tiny changes in the timing of these flashes, astronomers can tell that planets are there, orbiting the cosmic ghost. They are worlds circling a dead star's rhythmic, silent pulse, a heartbeat in a cosmic graveyard. The closest exoplanet to our solar system is Proxima Centauri b. It orbits the nearest star to our Sun, Proxima Centauri, a small, dim red dwarf. The planet is a rocky world, a little larger than Earth. It orbits very close to its star, so close that its year is only 11 Earth days long. Because its star is so cool and dim, the planet lies within the habitable zone, the region where liquid water could exist. It is our closest planetary neighbor outside our solar system, yet it remains a deep and profound mystery, a silent neighbor just next door in the cosmic sense. Many exoplanets are found in systems very different from our own. The TRAPPIST-1 system is a famous example. It has 7 known rocky planets, all similar in size to Earth. They all orbit their star, a tiny, cool red dwarf, much closer than Mercury orbits our Sun. They are a tight-knit family of worlds, huddled close to their small, dim star for warmth. From the surface of one of these planets, the other 6 would appear in the sky not as stars, but as large disks, like our own moon, or even larger, 7 sisters, circling a gentle, red sun. The region around a star where a planet could have liquid water on its surface is called the habitable zone, or the Goldilocks zone. It is the area that is not too hot and not too cold, but just right. Earth sits comfortably in our Sun's habitable zone. The size and location of this zone depends on the star. For a hot, bright star, the zone is large and far away. For a cool, dim star like Proxima Centauri, the zone is very small and very close to the star, a narrow, quiet ring where life might find a footing. A planet's ability to reflect light is called its albedo. A planet with a high albedo is very bright and reflects a lot of sunlight, like snow-covered Enceladus. A planet with a low albedo is dark and absorbs most of the light that hits it, like the charcoal dark rings of Uranus. A planet's albedo is important for its climate. A more reflective planet will be cooler, as it sends more of the star's energy back into space. It is a quiet measure of a world's brightness, a number that tells us how it greets the light. Some worlds may be ocean planets, planets that are covered entirely in a single global ocean, hundreds or even thousands of kilometers deep. On such a world, there would be no land at all. Beneath the waves, the pressure would become immense. In the crushing dark of the deep ocean, strange forms of ice might exist. Forms of ice that are created not by cold, but by the incredible pressure. A form of ice that is hot to the touch. It would be a world of an endless ocean under an alien sky, with a floor of exotic high-pressure ice. Other theoretical worlds are carbon planets. In a star system that is rich in carbon and poor in oxygen, planets might form very differently. Instead of silicate rocks, they could be made of carbides. Instead of water oceans, they might have oceans of oil or tar. And deep inside, the immense pressure could create thick layers of pure diamond. On such a world, there might be mountains of diamond and graphite, glittering under the light of a distant star. A world of unimaginable treasure, forged in the heart of a carbon-rich star system. There are objects in the cosmos that are neither star nor planet. They are called brown dwarfs. These are worlds that are much more massive than Jupiter, but not quite massive enough to start burning hydrogen in their cores like a true star. They are failed stars, glowing faintly with the leftover heat of their formation. They slowly cool and fade over billions of years, like giant dying embers drifting through space. Some of these lonely warm worlds may even have their own planets. A solar system lit only by a dim red glow. All planets are constantly bathed in a gentle, invisible stream called the solar wind. This is a flow of charged particles, electrons and protons, that are constantly streaming away from their star in all directions. A planet's magnetic field, its magnetosphere, acts like a protective shield or bubble. It deflects this wind around the planet, protecting the atmosphere from being slowly stripped away into space. It is a magnetic bubble, creating a safe, quiet harbor in the middle of a constant, silent cosmic storm. Where the solar wind interacts with a planet's magnetic field and atmosphere, it can create beautiful, silent light shows called auroras. We see them on Earth as the northern and southern lights, but they also happen on Jupiter, Saturn, Uranus, and Neptune. They are vast, shimmering curtains of light, dancing in the upper atmosphere of these giant worlds. They are a beautiful reminder of the invisible forces at play, a silent light show for no one in the dark skies of a gas giant. The path that most planets follow around the Sun lies on a flat, common plane. This plane is called the ecliptic. It is like a cosmic racetrack where all the planets run in their own lanes, at their own unique speeds. This is a remnant of the flat, spinning disk from which they all formed. When you see planets in the night sky, they always follow a similar path across the stars, because we are all traveling together on the same flat, quiet road through space. No planet's orbit is a perfect circle. They are all slightly oval-shaped, an ellipse. The measure of how stretched out an orbit is called its eccentricity. Some orbits, like Venus's, are very nearly circular. Others, like Mercury's and Pluto's, are much more eccentric, or stretched out. This slight imperfection in every orbit gives each planet's journey its own unique character and rhythm. A perfect circle with just a little bit of a wobble. In the space between planets, there are quiet points of perfect gravitational balance. These are called Lagrange points. Here, the gravitational pull of the Sun and a planet are perfectly equal, creating a stable or semi-stable pocket in space. A small object, like an asteroid or a space telescope, can sit in one of these points and remain there for a very long time, without using much energy. They are like quiet parking spots in the middle of the busy solar system, places of perfect gravitational stillness. Some tidally locked exoplanets that orbit red dwarf stars are called eyeball planets. The side that permanently faces the star is hot and dry, perhaps a vast desert. The side that permanently faces away is frozen solid, a shell of ice. But in the ring between them, there is a permanent twilight zone, a terminator line where the heat of the day side meets the cold of the night side. In this gentle, temperate ring, liquid water could exist, and life might thrive. It is a planet that looks like an eye, staring forever and without blinking at its sun. The sheer number of planets in our galaxy is a quiet and humbling wonder. It is now believed, based on what we have learned from telescopes like Kepler, that there are more planets than there are stars in the Milky Way. Our galaxy has hundreds of billions of stars, which means there are likely trillions of planets, billions upon billions of worlds, most of them unseen and unknown, are out there right now, drifting silently in the night, an endless number of quiet worlds, each with its own secret story. And with all these worlds, there is a great and profound quiet. The galaxy is ancient and vast, filled with countless places where life could arise. Yet when we listen to the stars, we hear only silence. This is the Fermi paradox. Perhaps life is very rare, or perhaps civilizations are very far apart, or perhaps they are quiet, just like us, listening to the gentle hum of their own worlds and wondering if anyone else is out there, a universe of listeners waiting in the great silence. And in the end, after billions or even trillions of years, a planet's long, silent journey will come to a close. As its star ages, it will change. A star like our sun will swell into a red giant, its outer layers expanding to gently consume the inner worlds, Mercury, Venus, and perhaps Earth. It is not a violent end, but a slow, quiet transformation. The planet's material returning to the star that gave it birth. A slow, final return to the heart of the star that made it. Our journey through the quiet worlds is now ending, but the planets continue their silent, graceful dance. They are a reminder of the slow, patient, and endless rhythm of the universe, a rhythm that lives inside you, too, in your own steady breath. Their endless, silent turning is a lullaby written across the fabric of the night sky. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe. Let your eyes close, and let the quiet orbits lull your thoughts to sleep. Good night.